Hello everyone and welcome to Science Roots. In today's session we are going to discuss Thevenin's theorem for DC circuits. Basically Thevenin's theorem can be applied for DC as well as AC circuits, but in this session we are going to understand Thevenin's theorem for DC circuit. First let us understand the statement of Thevenin's theorem. Any active linear bilateral network that contains one or more independent voltage or current sources that can be replaced by a simple network that consists of Thevenin's equivalent voltage source VTH and Thevenin's equivalent resistance RTH. This Thevenin's equivalent resistance RTH shall be connected in series with VTH. And once we calculate VTH and RTH, we can easily calculate the current that flows through the load resistance and can be calculated by applying simple Ohm's law, that is VTH upon RTH plus RL. So few points should be noted here. Meaning of active network. Active network is which contains voltage source or current source. The linear network wherein with change in voltage, change in current, the value of resistance will not change. Bilateral, the current can flow in any direction. That will be a bilateral network. So actually these are the different types of network. So in which we consider active, linear and bilateral network. The second important is independent voltage source. The dependent voltage source we usually consider for AC circuit, not for DC circuits. And the load resistance, the important part, the load resistance is the resistance through which current needs to be calculated. So in this case we can see here whatever is the complex network that consists of resistors connected in series, parallel or any complicated network can be reduced to simple equivalent Thevenin's network or circuit that consists of a voltage source VTH and a Thevenin's equivalent resistance RTH in series with VTH across the load resistance RL. So after understanding the theorem, let us proceed for understanding the steps to apply the Thevenin's theorem. So I have decided to calculate this Thevenin's theorem. We can apply 6 steps. Let us understand one by one step. So first step is temporarily remove the load resistance RL through which the current is to be calculated. So this load resistance through which we have to calculate the current, that we have to temporarily remove. Second step, across the open terminals, that is across the load resistance, we need to calculate the open circuit voltage, that is VOC or VTH. So VOC represents the open circuit voltage and that is nothing but the Thevenin's equivalent voltage source. The third step is to calculate the RTH, that is Thevenin's equivalent resistance. And how to calculate this equivalent resistance is in the complex circuit we need only resistances. So but there will be some active sources, we have to remove those active sources. So how to remove those active sources? Then one important note is mentioned. The voltage sources need to be replaced by short circuit and the current sources need to be replaced by the open circuit. So that in the entire circuit there will be only resistances, and across the open terminals we need to calculate the equivalent resistances by simplifying the network, that is in simple way by considering the series parallel combination. We need to calculate the RTH. Once we calculate RTH, the next step is step number 4, where we need to redraw or we need to draw the Thevenin's equivalent circuit mentioning the values of VTH and RTH. Then in step 5, we need to reconnect the load resistance that we have removed in step number 1. And at the end, we need to calculate the current through load resistance, that is simple Ohm's law, I equal to VTH upon RTH plus RL. After this, let us understand how to implement this concept in case of any numerical or example. Let us take a simple circuit for us to understand basically how this Thevenin's theorem is implemented. So I have taken one simple example where there are two loops and we need to calculate the current that is flowing through this 10 ohm resistor. Now this is a complicated circuit where we have multiple resistances, we have voltage sources, we have multiple voltage sources. So this is going to represent a complex network where we need to reduce into simple Thevenin's equivalent network VTH and a series resistance RTH across the load resistance RL. So let us understand the steps that we have applied. Let us see step by step for this particular numerical. So first step is temporarily remove the load resistance RL. So load resistance is 10 ohms. We have removed that load resistance RL, and across that open terminal we are going to now find the VTH. Now this is very interesting, that how to calculate this VTH. So first step, we have seen we have removed the load resistance RL. Now in the second step, across the open terminal we have to calculate the VTH, that is the open circuit voltage or Thevenin's equivalent voltage source. Now across the open terminals, we have to observe across the open terminals, and whatever branch we see across the open terminals, whatever is the voltage, total voltage drop across that entire branch will be the voltage across this terminals, that is going to give us VTH. As we all know that in parallel circuit, voltage is constant. So if I have to calculate the voltage across this terminals A and B, it is nothing but the voltage drop across this branch C and D. So simple thumb rule we can say that whenever a branch is open, we need to observe from the open terminals whichever is branch visible to us. From that branch or across that branch, we are going to calculate the VTH. Now let us calculate the open circuit voltage or the voltage drop across the branch CD. For that we need to calculate the voltage drop across this 6 ohms, and for that we need to calculate this current I. So this current I can be calculated by considering a simple loop, that is ECDFE. So this is one loop that we will consider and apply simple KVL. So we have here -5 I1. The sign conventions, for the sign conventions you can refer the previous video session that was on the Kirchhoff's voltage law. So applying KVL, we get -5 I1, then -6 for the voltage source, again -6 I, and we are going towards positive terminal of the battery, so +9. We have this equation equal to 0. So on simplifying the equation, I will get 11I equal to 3, and I will get the value of current that comes to be 0.72. So to calculate the voltage drop across 6 ohm resistor, so V equal to IR, that is the simple Ohm's law. So current and resistance multiplication or the product will give me the voltage drop. So that is what I have calculated over here. So 6 into the current, 6 is the voltage, the resistance value, and 0.272 is the current in that particular loop. I got the value as 1.632 along with the polarity. So you can see here positive and negative polarity. Now these two polarities will be added because it is negative and positive. So the total VTH now will be 6 plus 1.632, which gives me 7.632. That is the VTH. So this is the second step where we have removed the voltage, we have removed the resistance and calculated the open circuit voltage VTH or Thevenin's equivalent voltage. The next step, as we have discussed, is to calculate RTH. So if we observe here, whatever is the voltage source, this 9 volt and 6 volt has been replaced by short circuit. So the 9 volt was here and 6 volt was here. So we have replaced this with short circuit. And now in the circuit, we can only see the resistances. Now across this open terminals, as I have mentioned, we have to calculate the RTH. Now we have to consider the end exactly opposite to open circuit. So the exactly opposite end is this 5 and 6 ohm. These two resistors are connected in parallel. So we need to calculate the parallel equivalent, that comes to be 2.72 ohms. And once we calculate the parallel combination, we need to redraw the circuit and the remaining two resistors are connected in series. So that series equivalent will be 6.72 ohms. So this is actually the value of RTH. So RTH we got as 6.72 ohms. Now once we calculate the value of VTH and RTH, we need to redraw the Thevenin's equivalent circuit, where we have mentioned the value of VTH, we have mentioned the value of RTH, and we need to reconnect the load resistance RL that was removed in step 1. I'm mentioning here again, the load resistance RL is the resistance through which we have to calculate the current that is mentioned in the question. And in the final step, we need to calculate the current through load resistance RL by considering the simple loop for calculating the current I, VTH divided by RTH plus RL. So VTH is 7.632, RTH we got 6.72 plus 10 ohm, that is the load resistance, which comes to be 0.456 amperes. So hope this is very helpful for you. If any more suggestions, you are welcome. You can mention your suggestions or any in the comment section. And whatever the example we have solved with Kirchhoff's voltage law, you can try it with this Thevenin's equivalent circuit. Ultimately, you are going to get the same value of current. So that is going to be an additional task for you. You can just try. Any query, I'm waiting for your comments. Thank you. Have a nice day.